Welcome to E-Academy. My name is Mr. Carlson. We're going to be looking at a geometry lesson today in which we want to be able to determine if lines are perpendicular to each other by using their equations. This is a power standard number of 11 for the geometry course. Let's get started. Alright, to begin with, I have on the screen here, I have two lines that are perpendicular to each other. Remember, perpendicular means that they form a 90-degree angle when they intersect. So these two lines, the red line and the blue line, would be perpendicular to each other. Now what we want to do today is we want to look at the equations of those lines and determine what's unique about the equations, such that when we look at just the equations we can determine whether or not those lines are perpendicular. Alright, in order for us to determine if two lines are perpendicular to each other, just from looking at their equations, what we need is the perpendicular lines and slopes theorem, and that tells us that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. In other words, if we multiply their slopes together and we get -1, then we know that those lines are perpendicular to each other. Well, another way of looking at that is by looking at the slopes and seeing if they are opposite reciprocals. In other words, if you think about it in terms of fractions, if we look at one fraction, the other one will be flipped over and the sign will be changed. Okay? Alright, in the first example here I'm asking, are these two lines perpendicular? Well, we actually already know they're perpendicular because these are the equations from the two lines on the previous screen. Of the two lines that we showed were equal, that intersected at a 90-degree angle. So what I want to do is these are already written in slope-intercept form, and remember, slope-intercept form is y equals mx plus b. And in slope-intercept form we know the coefficient that comes in front of x is always our slope. So if I look at these two lines, this is the slope of this line and this is the slope of this line. Okay? Well, if we think about those in terms of is the product -1, if I take -2 and I multiply it by 0.5, you'll notice that we get -1. So we know that those are perpendicular to each other. Now I also mentioned that their slopes are opposite reciprocals of each other. So if I write those as fractions, one would be -2 over 1. And the other one would be 1/2. Okay? You'll notice that their fractions are flipped over and their signs have been changed. This one would be positive. Okay? So the easiest way to see it is to look to see if their slopes are negative reciprocals of each other. Alright, example number 2 is just a little bit harder. Instead of having our lines, the equations for our lines written in slope-intercept form, we don't have that anymore. So what we need to do in order to check to see if they're perpendicular is we need to first write them in slope-intercept form. So I'm going to take this first equation here and I want to write that in slope-intercept form. So I'm going to try and solve that for y, really, because we want it to look like this right up here. So what I'm going to do is I'm going to start by subtracting 6x from both sides, which gives me -4y. Don't forget to bring the negative down with the 4y, is equal to, and I'm going to put the x term first because I want it to look like this up here. So I have -6x minus 12, and that minus sign goes with it. And then I'm going to go ahead and divide by -4 to each term, and when I do that I'm left with y equals, now we want to simplify this. Okay? So I can take the number and write that as a fraction out front. So if I have a -6 over a -4, the negatives are going to cancel out. 6 and 4 can be, I can simplify that fraction to 3 over 2 times x. And then -12 over a -4 is going to give me a +3. So I have this now in slope-intercept form. Okay. Can you just pause the video now at this time and see if you can put the other equation in slope-intercept form? Then I'll put it up here and we'll take a look and see if we can determine whether these are perpendicular or not. Alright, check your equation in slope-intercept form, see if it matches mine. This is what I ended up with. And you'll notice as I look at it that this is the slope of this line, negative 2/3. And the slope of the line over here is 3/2. Okay? And you'll also notice that these are reciprocals of each other and they're opposite signs. So the product of their slope should be equal to -1, which means that they are perpendicular to each other. So these are perpendicular lines. And just to show that, let's take and multiply those two slopes together and show that it equals -1. 3/2 times -2/3, which gives me -6 over 6, which is equal to -1. And it checks out. So those two lines would also be considered perpendicular to each other.